Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. So today we'll discuss, I have decided to discuss only calculus because it's been a while that we have discussed calculus long ago, right? So instead of directly putting into electrostatics and discussing, I thought let us have a introduction to calculus or electrostatics so that when we do calculus in electrostatics, you will not find it that much of a difficulty.
Yes, sir.
Fine. So let's discuss calculus for electrostatics. Okay. Most of the things I'm sure you remember, but let us see how much you remember and how much you don't remember. We'll figure it out now. Okay. So first thing in calculus is differentiation, and in differentiation, what do we say? Differential of x power n is n x to the power n minus 1 dx. Correct?
Yes, sir.
Even before that, what is differentiation in layman terms? Differentiation is subtraction.
Yes, sir.
We have physical quantities and chemical quantities in science. Certain physical quantities, because we are going to focus on physical quantities. Certain physical quantities, we take it as a constant. For example, universal gravitational constant or universal gas constant. These we always take it as a constant. So certain physical quantities we take it as a constant, whereas certain physical quantities we come across as a variable. So calculus comes for the part where we have variables, correct?
Yes, sir.
Also in variables, there are two kinds of variables. For example, if we discuss that when I was 5 years old, I had a height of, let's say, half a meter probably, or 3/4 of a meter. Today I have a height of 1.75 meters, let's say. So that difference is from one point to another point, right? So the change that we're talking of is a significant change. So that for that also we don't require calculus. We use delta for that, right? For significant change. So specifically, where do I use calculus? I use calculus where the physical quantity is more or less varying on the basis of some other physical quantity. Y is a function of x, is the place where I am going to use my calculus part. Is this clear?
Yes, sir.
One of the examples that I usually give is if you have to find out the length of my shoulder from here to here, we can't do it with a scale.
Yes, sir.
Because this is a continuously varying curvature. What is varying? The tangent is varying, right?
Yes, sir.
The tangent is constantly varying. So to find the length from this part to this part, what I have to do is more or less calculus. Is this clear?
Yes, sir.
So in calculus, the first thing is differentiation. And what is differentiation? Differentiation is nothing but subtraction. Okay? Clear?
Yes, sir.
Differentiation is nothing but subtraction. Is this visible to you, this height?
Actually, no.
Okay.
But I can see.
No, then.
Calculus for electricity.
Yeah, I'll just write it a little bit lower. What we are seeing is differentiation is nothing but subtraction, right?
Yes, sir.
And if you remember, we write dy as nothing but y2 minus y1. Simple. Infinite
Yes, sir.
small change in y is nothing but differentiation of y, dy. Clear?
Yes, sir.
Infinite small change in my physical quantity y is, we write it as, mathematically we write it as dy, and that's called the differential element of y.
Yes, sir.
Now in place of y, if I have x power n, then my differentiation will be n x to the power n minus 1, correct?
Yes, sir.
Next, if you remember, a differential of a constant, we get it as 0.
Yeah.
Similarly, if I have differential of a constant into a function, so that means differential of, I have a constant, let us say, okay, where a is a constant, and this constant is multiplied with a function, some function f of x, then I can bring this constant out and multiply it with the differential of f of x, correct?
Yes. Yes, sir.
Then another thing that we saw is that if we have two different functions, differential of p plus or minus q, if two functions p and q are added or subtracted. So here we have p and q as, we can say, we can say they are variables or we can say they are functions. So we will write it as differential of p plus or minus. So we can differentiate individual in an individual way, right?
Yes, sir.
So let us just do few examples to make sure that we are. So suppose I have differential of 3t square plus 6t cube. How much will I get it? Tell me.
60 plus 6. And
60 plus 18t square dt.
So that is 3.
Yeah, t cube.
Okay.
Okay.
Yes, sir.
Okay. So differential of, let's say, 8x to the power 4 minus 5x to the power 10. We'll get it as
32x power 3 minus 50x power 9.
and we will also get dx.
30x. Yeah.
Correct. So here one of the points that we have to remember is whenever we differentiate, we will get a differential element. This is a very important statement which we will see it in future now. Okay, even in electricity and magnetism chapter we will see.
Yes, sir.
Whenever we differentiate, we will get a differential element. Correct?
Yes, sir.
Now similarly, there are other formulas. For example, differential of e power x, I'll get it as e power x dx. Correct?
Yes, sir.
Trigonometric functions, differential of sine x is,
It's because cross multiplying the dx in the denominator.
sorry, what?
So it's like cross multiplying the dx.
Okay, so basically this dx is usually written in the denominator, right? Okay.
Yes, sir.
Differential of sine x is
Cos x.
cos x dx. Differential
Yes.
of cos x is
Minus sin x dx.
minus sin x dx. Differential of tan x
Secant square x.
is secant square x dx. Differential of secant x is,
Secant x tan x.
okay. So basically, more or less, you remember these things so we can move ahead, right?
Yes, sir.
Now, there is the next thing, important thing that we have in differentiation is differentiation by substitution, right? differentiation by substitution. Do you remember this?
Yes, sir. Chain rule.
Chain rule. So simply if we have differential of some function f of g of x, but we are differentiating it with respect to x, then I will write this as
F dash of G of X.
f of t by dt into, I'll write dt by dx. Basically, I am substituting what? I am substituting gx as t. Is this?
Whenever we substitute, we differentiate.
And whenever we substitute, we differentiate. Good point. So, whenever we substitute, we should differentiate. Why should we differentiate whenever we substitute?
I forgot. You told, but I forgot.
Whenever we substitute, we should differentiate because I told you the differential element. First point is the variable that we have. What is variable? Variable is x. Correct?
Yes, sir.
The differential element of that variable, I will write it as dx. Correct?
Yes, sir.
So first point is, I told you that the variable x and the differential element of that variable dx are two different things. Very important point. Again, this also, application of this also will be used in our electricity and magnetism. In physics,
But dx is a part of x.
dx is
No.
infinite small change in x, whereas x is something else.
Yes, sir.
Is this clear?
Yes, sir.
I was riding my friend's racer bike, let's say, on an empty flat road.
Yes,
And
sir.
let's say I'm riding it in some 5th gear or 6th gear. I don't know how much that racer bike gears are. So just to put it in layman terms, I took a friend's racer bike and I am riding that bike on a flat, neat road, horizontal road where nobody is there and the road is also wide and very long. And I am driving that vehicle, that's bike, let's say at a speed of 200 kilometers per hour. That part will be, let us say, for half an hour, 1 hour.
Yes, sir.
That is just a differential element of what Anil is. But Anil is not that. I am not always driving high speed.
Yes, sir.
So, if X is Anil, that moment where I am driving the vehicle for, let's say, some 15 minutes or half an hour is a small part of my entire life.
Yes, sir.
Is this clear?
Yes, sir.
So, my entire life and who I am is different, way different from that 15 minutes of what you see.
The speed of light with respect to our walk.
I am not comparing just the speeds. I am comparing in a very general sense. I am comparing if somebody looks at 15 minutes of me and makes an impression that, oh, this fellow is a speeder, he always drives bikes fast. That's a wrong thing, right?
Yes, sir.
So, me driving or me teaching for 1 hour right now is different from what I am in my entire life. You can't imprint this onto my entire life. So if X is basically my entire life, dx is a very small element of it. It's a differential element of X. What is differential element? It's nothing but subtraction. So from last 20 minutes to the next 20 minutes, subtract it, you will get some 40 minutes of time interval. But X is my entire life,
Yes, sir.
right? So if you watch me for 40 minutes of lecturing or 15 minutes of driving and think that is only Anil's life, that's not right. That's not correct. I sleep also, I eat also, I play also.
Yes,
Are you
sir.
getting my point? So
Yes, sir.
simply in a very generalized way, what I'm trying to say is the differential element of a variable is way different from what the variable itself is.
Yes, sir.
Very small example regarding that. Differential of sine x is cos x. Sin x and cos x are way different. Sin 30 is half, sin cos 30 is root 3 by 2.
Yes, sir.
Only at 45 degree they are same. Sin 45 and cos 45. Sin 90, sin 0 is 0, cos 0 is 1. Sin 90 is 1, cos 90 is 0. But differential of sine will give you cos. So the function sin x and the function differential of sin x, which is cos x, are way different from each other. Is this clear?
Yes, sir.
Similarly, the function tan x and the other function differential of tan x, which is secant square x, are way different from that. We can't say tan x is equal to secant square x. Not true.
Yes, sir.
Similarly, the variable x and the differential element of that variable are two different things. The application
Yes.
of this is going to come in our electricity and magnetism, and one of the very important things in electricity and magnetism, understanding of electricity and magnetism. Okay,
Yes, sir.
is this clear?
Yes, sir.
Coming back to our original point, whenever we substitute, we should differentiate. The question was, why should I differentiate? Because when I substituted, I introduced a new variable t.
Yes, sir.
If I am knowing the variable t, then I should also know the differential element dt.
Yes, sir.
That's the reason we differentiate. It can be velocity of your car, it can be velocity of a rocket, it can be the gas that is coming out of the ejected out of the rocket, it can be how many dogs bark at night. The function can be anything, it doesn't matter. If you introduce a variable, you should also know the differential element of that variable.
Yes, sir.
Okay. In certain questions, you will get the direct usage of the differential element of that variable. In certain questions, you might not need, but it is better to know the differential element of the variable. Therefore, whenever we substitute, we should always differentiate so that I can get to know what is the differential element of t. So now I know t, right?
Yes, sir.
After differentiating differential of g of x, now I know dt. So I know t, I know dt. Great.
Yes, sir.
Here again, one question might come. What will I do with this dt? But for that, we need to look at the application part of it, right? We don't have to go into mathematics completely right now. The real expression of why this is important, we will get it in few lectures only, in electrostatics only.
Yes, sir.
Is this clear?
Yes, sir.
Fine. And this holds even in integration also. So, keeping this in mind, let us just look at some examples. Same examples that we've done previously also. Suppose I have differential of sine of cos x. Sine of cos x, right? So I'll
Yes.
substitute the inner function cos x is equal to t. Fine. Now, according to the previous thing, I have to know the differential element of it also. So what is differential of cos x? It is sin x dx.
Minus sign.
Minus sin x dx. Good. So differential of cos x is minus sin x dx. So now my job is done. I substituted it as a new element, and now I also know the differential element of it. Clear?
Yes, sir.
Now let us solve the problem. So what will happen? This will become differential of...
Will be cos of cos x into
Correct.
minus.
So differential of sin t is cos t, and we will also get dt. Correct?
Yes, sir.
See, here only we can see the application of why I need the differential element. Because the differential element I'll substitute over here.
Yes, sir.
Right? So the answer will be cos of cos x into minus sin x dx. Is this clear?
Yes, sir.
We will do just a few more examples. For example, I have differential of e to the power 2x plus 3.
It will be e power 2x plus 3 into 2.
Correct. But you missed one small thing. Into, whenever we differentiate, we will get the differential element.
Yes, sir.
Okay, what is differential of ln x?
1 by x.
1 by x dx, right? So I can
Yes.
say it is dx by x. Now suppose I have differential of ln of 2x plus 3. Now what will I get answer as?
1 by 2x plus 3 into 2.
Into dx also. So can I write it as 2 dx by 2x plus 3?
Yes, sir.
Or the 2 will it be in denominator?
No, sir.
Good. So let's just solve one last thing. Let us make a combination of differential of ln e to the power x. Ln of e to the power x.
1 by e power x into e power x 1, sir.
See, for that, correct answer, but what
It
I
will
am
be dx, sir.
saying is, if you have ln e power x, this itself is x, right?
Yes, sir.
X will come out. Ln e base e is 1. So this itself is x. So basically this is dx only. I just was having fun. Is it clear?
Yes, sir.
Xerox. So in differentiation, apart from this, we have our UV, right? Product.
Yes, sir.
And division also. So I'll just write it over here. I don't want to solve anything on product or division. So just two more things that we have is differential of UV is U dV plus V du, and differential of U by V is V du minus U dV divided by V square. Right?
Yes, sir.
Take that down. Done?
Yes, sir.
See, now the graphical usage or graphical representation of. So I think you should remember this because I told you graphical representation. So suppose I have a y as a function of x, a random function. This is x-axis, that is y-axis, and let us say we have a random function. Okay. At a particular distance, at a particular point, Suppose if I will do differentiation dy by dx, what will I get? At a particular point, if we differentiate, what will we get?
dx was no.
Very
I-
important thing. So at this particular point, let's say this is point P. If I draw a tangent, right? This fellow is called a tangent. So if I do dy by dx at that particular point, I will get the slope of tangent.
Okay, sir.
Do you remember this?
Yes, sir.
So dy by dx is nothing but slope of tangent at that point. Or you can say at a point or at that point. Yeah?
Yes, sir.
dy by dx is nothing but slope of tangent. Geometrically, it's slope of tangent at that point.
Yes, sir.
And for this function that I have drawn, this graph that I have drawn, we can clearly see that the slope of this tangent is a variable.
Yes, sir.
Is this clear?
Yes, sir.
Fine. Now let us go to our integration part. So integration in a good. Integration is nothing but addition. Differentiation is subtraction. Integration is addition. And the sense of it is basically addition. And in terms of equations, we can say differentiation and integration are two opposite operators, right? Differentiation and integration are two opposite operators. In the sense, suppose I have differential of sin x. If I have, I'll get it as cos x dx. Correct?
Yes, sir.
But for the same thing, if I do reverse integration of, if I do cos x dx,
We get sin x.
we get the inner function. Or I can write this cos x dx is nothing but, so integral of differential of sin x, I can write it, right?
Yes, sir.
In the place of cos x dx, I just wrote differential of sin x. And integral of differentiation, these two are opposite functions, therefore I will get this as sin x. Correct? Is this clear?
What is integration of differentiation of sin x, sir?
We have integration of cos x dx.
It will be integration of sin x then.
No.
Cos x.
I am saying we have integral of cos x dx, right?
Yes, sir.
In the place of cos x
Yes,
dx,
sir, I understand.
I can write differential of sin x. And here I am saying integral and differential are two opposite functions. When I do them together, they'll cancel each other.
Yes, sir.
So I'll get the same function that I have inside the differential. Correct?
Yes, sir.
So integral cos x dx is sin x.
Yes, sir.
Rajni? This is an indefinite integration, so we will have a constant.
Yes, sir.
Whenever we do indefinite integration, we will always get a constant. We should never forget that, right?
Yes, sir.
Similarly, if I have integral of a constant where a is a constant and into some function f of x dx, I can take a out and I can write the rest of it the same. Similarly, if I have addition or subtraction of two different functions,
separately.
So I'm writing p, q as some two variables, or you can say they are two functions, right? into
Yes.
dx. I can do integral of p dx separately plus or minus integral of q dx separately. Correct?
Yes, sir.
Similarly, according to our previous formulas in differentiation, for integration, if I'll do integral x to the power n dx, what should I get? X to the power n plus 1 by n plus 1 plus c. Correct?
Yes, sir.
Similarly, if I do integral of dx upon x, so previously we saw differential of ln x is 1 by x. So if I
Yes,
do
sir.
integral of 1 by x dx, I should get ln x plus c.
Yes, sir.
Similarly, if I have integral of e power x dx, I will get e power x plus c.
Yes, sir.
Is this clear?
Yes, sir.
So on and so forth. Again, in just like differentiation, in integration also we have formulas. Now let us solve few examples on the formulas that we have discussed just now, right? So suppose I have integral of, let us say I have integral of sine x plus x to the power 5 dx. What should I get?
It should be integration of sin x will be minus cos x
Minus cos x
plus x power 6 by 6
plus x to the power 6
plus
upon 6
c.
and a constant plus c. Fine.
Because there are no limits, we are taking the constant.
Suppose if I do integral of, let us say, simple x minus 1 by x. This is a very common question, right?
Yes, sir.
What will I get the answer as?
X square by 2
X square by 2
minus 1.
minus ln x plus a
We
constant.
can take it 1 by x as x power minus 1.
But you can do that. That you'll get in the denominator minus 1 plus 1, you'll get 0.
Okay, that is
Not defined. And I already wrote integral dx by x is ln x plus c.
yes, sir.
The reason I wrote it after that was basically when you have x to the power minus 1, you can't, that integration will not work.
Yes, sir.
Right? So basically x square by 2 minus ln x plus c. Clear?
Yes, sir.
Let us look at the very important thing that we are going to use for electrostatics and the other chapters that we are going to get is integration by substitution. Okay? Integration by substitution.
Should we substitute an integration also?
Yes. So
Yes, sir.
focus. Okay. How am I going to do integration by substitution? Integration by substitution, I should have a form of if I have something like this, integral of f of into g of x dx. Okay.
Yes, sir.
If I have something of the form integral of f of x into g of x dx, where the function g of x is nothing but differential of f of x. The function g of x,
Sir, so that is the condition that you have given.
that's the condition that we need to have in the question only.
Okay.
The function g of x dx is nothing but differential of f of x.
Yes, sir.
Then I can take, in this case I can take f of x as some t and solve it. then I'll take the function f of x as some t and solve it.
Sir, g of x dx is differential of f of x. Then it is f of x into differential of f of x. Oh,
I'm coming there.
yes, sir.
See, what we are trying to understand here is that I need to have the differential of one of the functions as a product over here to solve the integration by substitution.
Mm.
Here I have taken f of x as t. Correct?
Yes, sir.
Whenever we substitute, we should differentiate.
Differentiate.
So basically, I will get differential of f of x is what? dt.
Mm.
But differential of f of x itself is g of x dx.
Yes, sir.
Clear? Differential
Yes.
of f of x itself is g of x dx. Is this clear?
Yes, sir.
Now, the question will eventually transform itself as integral of what is f of x?
into dt.
F of x is t.
Yeah.
F of x is t.
T dt.
What is integral t dt?
T squared by
Plus
t squared
c.
by 2.
What is t is nothing but f of x.
Yes, sir.
I want the answer in terms of x, right? Because question is given in terms of x. So I will get the answer as f of x whole square divided by 2 plus c. This is how we do the integration part.
Yes, sir.
Is this clear?
Yes, sir.
Xerox. Just take a look, okay? There are only two things now. We will discuss one question or two questions on integration by substitution. Then we will focus on the geometrical representation of integration, okay?
Yes, sir.
See, if suppose we have integral of f of g of x into g dash of x dx. If this form is also given, we can do integration by substitution.
Yes, sir.
How? In this case, I will take g of x is equal to t. Then I will get...
There's no condition mentioned in the question.
No, the condition is this. Whatever function is there inside of f, the differential of that should be outside of f as a product of f. Okay?
Yes, sir.
So when I have g of x and g dash of x like this, I can do integration by substitution. How? I will take g of x as t, then g dash of x dx will become dt. Right?
Yes, sir.
So my question will become what? Integral of f of t dt.
Yes, sir.
Is this clear?
Yes, sir.
Now depending on f, that is sine, cos, e power, whatever it is, we can just solve it that way. Fine? Clear?
Yes, sir.
See, suppose I have integral of sine x into cos x dx. Okay, I'm just giving this as an example. If I have integral of sine x into cos x dx, I will have what? Sine x is equal to t, correct?
Yes, sir.
Whenever we substitute, we should differentiate. So this cos x dx will become dt.
dt.
Right?
Yes, sir.
My question eventually will become integral of sine t into dt. What is integral sine t?
Minus cos.
Minus cos t. So the answer will be minus cos t plus c, and we have to write it in terms of x. So this is minus cos of t is nothing but sin x, right?
Yes, sir.
Let's see. Is this clear?
Yes, sir.
One question I will solve, which is we will use this repeatedly in our electrostatics and all these chapters. Suppose I have integral of a square plus x square whole to the power 3 by 2, and I have x dx in the numerator.
Yes, sir.
A is a constant. A is a constant. Okay.
Yes, sir.
I should have, what is the condition? I should have a function g of x such that its differential should be outside in the integral, right? I have a function x square whose differential is 2x dx, right? If I multiply a constant, I can get 2x dx.
Could you tell it again?
I have x square.
Yes, sir.
Differential of x square is 2x dx.
Yes, sir.
I should have that in my question only, right?
Yes, sir.
If I multiply by 2 and divide by 2, anyways it's a constant, I will have 2x dx in the numerator, right? This can be done by integration, by substitution is what I am saying.
Yes, sir.
Easily. And what is that function f? What is that f function? F is nothing but 3 to the power 3 by 2.
Yes, sir.
But anyways, simply how will I solve this? I will say a square plus x square. Instead of saying t, I will say t square, because by 2 is there here, right? Now, whenever we substitute, we differentiate. When we differentiate, 2 will get cancelled both sides. I will get this, correct?
Yes, sir.
So my question eventually will be what? X dx is nothing but t dt divided by t square to the power 3 by 2. Be how much?
T cube.
T cube. 1 by t square?
T cube. Yes, sir. 1 by t square.
1 by t square.
Yes, sir.
Goes into the numerator, t to the power minus 2.
Yes, sir.
Minus 2 plus 1 by minus 2 plus
1. Yes, sir.
Which is minus 1. So simply I'm directly writing the answer as minus 1 by t plus c. Clear?
Yes, sir.
So what will I see? I have to write the answer in terms of x. So what will I get this as? Minus 1 by under root of a square plus x square plus c.
Yes, sir.
Is this clear?
Yes, sir.
Understood. Okay. So now we have graphical representation.
We have area under the graph.
Good. Graphical representation is nothing but if I have x-axis, y-axis.
F of the curve.
So what will I get? I will get area under the curvature. Correct?
Yes, sir.
Integral of. And if suppose this is a definite integral,
we take limits.
So if I have integral of f of x dx, I know this is area under the curve on x-axis. Correct?
Yes, sir.
On x-axis. And if I have limits, suppose integral of f of x dx is some g of x plus c. Then from integral x1 to x2, f of x dx, I can write this as g of upper limit, correct? Minus
lower limit.
Lower limit. And I don't have to write any plus c over here. Is this clear?
Yes, sir.
Now, hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.